Hey folks, welcome back. Thank you so much for continuing to hang with us here live on the expo floor at AWS reInvent 2025. My name is Adrian San Miguel. I'm a principal partner solutions architect here at AWS working with technology partners. I know it's a lot of information. Just think tech go brr, I go boom. I'm joined to my right by a very good friend of mine, the lovely, the illustrious Jasmine.
Wow, there's so many different ways to describe me.
Thank
you so much. Hi, I'm Jasmine Kyles. I'm a senior product manager here at AWS, supporting all things AWS Partner Network and Marketplace. But I'm so excited to be joined by some new friends. Who do we have here?
I'm Dean. I'm from the CEO of Descartes. We're a customer. We're using Tranium. We're going to be seeing some really cool stuff today.
Ooh, so this is the Tranium session. Yes. All right.
Yeah, and my name's Matt. So I lead the customer engineering team in Annapurna Labs. So we're the team that builds, that delivers the Tranium and inferential services.
Okay, awesome. All right. For the audience who's new here, what is Tranium?
Yeah, so Tranium is essentially our custom AI chip for training and deploying deep learning models, especially foundational Gen AI models. So we deliver this through EC2 instances, so customers can spin them up. And yeah, we're excited with some new launches this week.
I might have already known the answer because I've worked with Matt, and I guess you can say worked for Matt for a while now. What can you tell us about the launches that have happened this week, Matt? And what was particularly the proudest or the most impactful for you?
Sure. So yeah, this week we launched our 4th generation AI chip, which is Tranium3. We're super excited because it delivers, twice the performance of our previous generation, which is a Tranium 2 chip. And yeah, I'm proud of essentially what our customers are doing. We've got customers like Descartes who are using this technology, as well as others like Anthropic doing amazing things at super large scale.
Yeah.
Now, when you say large scale, at Amazon, we're fairly large scale in a lot of the things that we do. But coming from an infrastructure background, when I was starting to read the spec sheets, the information, and reading up to help partners and customers figure out what this next new thing was going to be, I was kind of blown away with even just something as simple as networking bandwidth, something we all take for granted. Matt, what can you tell us about the networking bandwidth difference, just in between these different generations?
Yeah, sure. So, these models, need a lot of high bandwidth, low latency communication. So when we're going to Tranium 3, we've launched what we call UltraServers, and that actually offers, terabytes of bandwidth between these chips, right? Because these are, communicating at as I said, very high bandwidth, low latency, which is needed to deliver the kind of performance our customers expect.
Now, that is very interesting and very exciting. Jasmine, what are you hearing out in the streets from our customers and partners about what they're starting to explore as far as use cases go, levels of interest, and the things that they're wanting to do?
They just can't get enough of it. I've heard a wide variety of use cases from our partners and customers, and everything from like consumer goods over to what do we have here? Like our tech partners who are building with other customers who want to hit the ground running and fast and have something that they know is super reliable. So like, the possibilities are endless, and I love that every time I come to something like this or get on a new call, there's something new that's been built with it.
Yeah, absolutely. Yeah, we've got amazing customers. Obviously, the famous one is Anthropic, right? We launched Project Rainier. We have 500,000 chips that we've deployed into that, and we're actually expanding to 1 million chips for them. We've got other customers like Splash Music. They're doing music generation, using our chips. Customers like Ricoh in the manufacturing space in Japan. They're also doing some real use cases. We've got Descartes here today with a super cool demo of a video to video, which is another kind of use case and super interesting, also using Tranium.
Really, video to video. That's not really one of the ones that I would think that would come really intuitive, but now that you kind of say it out loud, what does that mean for you and your organization?
Oh, nice.
Hate to put you on the spot, but that's kind of what we do here.
By the way, I think we'll get in a sec, but the low latency, high bandwidth peer-to-peer networking is really something that we're using a lot. It's really been what's enabling our workload. I think we can show a demo of so the viewers and the audience can get to see what we're doing.
Okay, yeah, please.
if you look at my screen, so this is happening live right now, okay? I can turn into this lightning powered up scene. Here we have some hair. It added some hair. Look at that.
Oh,
Nice.
how do I make that happen in real life?
That's the next product we're working on.
I was about to say, this is what we would absolutely classify as a Gen AI hallucination. There is no hair there.
But a good one.
It's a
Sometimes
good
they're
one. Yeah.
We can be pirates. We can put on a suit if we want to be slightly more formal for a reInvent.
Okay.
We can decide that we want to go racing.
Wow.
That has been my favorite one. Like, big race
look at
just
us.
ended here
Look
in
at this.
Vegas, and look at me, like, vroom vroom.
Yeah. You look
we should.
I'm just saying.
Yeah.
We should do something cool. We should do something cool.
Let's do it.
Here. What do you think of this?
Adrian, look at our matching jacket.
It's not much of a stretch. I got my biker jacket over there.
Right. This is how we should be at
cool.
reInvent.
Yeah.
It's a completely different style.
I love it.
I mean, it's more my speed, to be completely honest with you. Given my music taste and the things that I do outside of work, this is 100% more the angle I dress for.
So now you can do it during work. You can do it after work.
Yeah.
We've seen this take off in so many different markets. On Amazon, Twitch as well. Streamers are using it to create just completely new experiences. We're taking this into shopping and ads, product placement. Imagine that if you want to sell a product, you want to sell a lamp or something, we can add it in the stream here.
Yeah.
You can add it to any video surface wherever you want. We have this running up on Trn3.
Okay.
It's we're gonna see a lot of that, and Trn3 really has been an enabler for this workload.
All right, so this is where I get to grok out a little bit. So, in the world of where everything's not quite fast enough, or it needs to be faster, this is pretty damn fast. Thinking about from the nuts and bolts of it, the API calls that are being made as you're moving around and clicking things. This is an API call in the background. It's going to an EC2 instance running Trn3.
Exactly.
It's computing. It's doing the thing. It's transcoding. It's re-uploading in fractions of a second.
Yep.
I mean, this is a testament to the level of integration, the amount of bandwidth, the raw processing power. I've been doing infrastructure and servers for a very long time, and I don't think I've ever seen anything as snappy and responsive as this. I mean, there's really no lag, no judder, no nothing flickering. It's rather instantaneous.
Yeah.
I mean,
no, it's a proof, I would say, to, first of all, their team, the skills that they have and the innovations that they've come with, but also, the infrastructure, right? Ultimately, all of these things have to run somewhere, and Trn3 is really able to deliver, which we're super proud of.
How did you know that you needed to use Trn3? Like, what were some of the things that you looked at when you saw the requirements? What did you know you needed to make your product reliable?
So I think that's a great question, and at the end of the day, these products, to be able to get low latency like this, or by the way, this is incredibly cheap, roughly 100x cheaper than any video model on the market.
Really?
Yes, and to get this, it's running at 40 milliseconds delay.
Okay.
Which is just nothing. To do that, you really need to be vertically integrated. You need to combine all the way from the software up at the highest levels, all the way down to the chip itself.
Okay.
And that's what's enabling this. Our work with Annapurna inside AWS on the Trainium chips to vertically integrate our models and their chips so that everything just works as one big box that's very low latency in between all the pieces.
You'd say one big box, and it almost sounds very romanticized and super simple. I mean, at the end of the day, there's some serious horsepower going on back there. We like to throw around the terms teraflops, memory bandwidth. What can you tell us, Mark, about what's going on behind the scenes on these servers?
Yeah, I mean, there are literally, like petaflops of compute in these machines, especially the UltraServers.
Petaflops, I'm sorry. I'm sorry on into with lowly teraflops. I'm sorry.
No, teraflops, we've moved on from teraflops. That's
clearly.
Like last year.
Clearly.
So just with the UltraServers, it's essentially 4.4 times more compute in Trn3 UltraServers than our previous gen. It's not just compute, though. Like a lot of people talk about the compute. It's actually the memory bandwidth is also really key, right?
Really?
You've got to think about, you've got to load all these parameters that are sitting in memory into the chip itself so it can actually do all these computations. And with Trn3 UltraServers, there's actually 3.9 times more memory bandwidth in this compared to the previous gen. So it again helps these models perform that well.
Yeah, we can touch on that as well. We're seeing what we're trying to optimize with Trn3 We're not there yet, but we're on a path. We're on a path to getting to over 100 FPS on this.
Wow.
Okay.
Yeah, frames per second. Yeah.
Yeah.
Frames per second, 100 frames per second. That's a frame generated every 0.01 seconds.
Okay.
As a very poor online gamer, I admit PvP is not my jam. It's all about PvE, where the inanimate object doesn't fight back. 100 frames per second is nuts.
And we can really only get that because of the networking. Because if you think about it, if we try to make it, to simplify it a bit, our model, it has 3 components.
Yep.
It has an LLM that does reasoning that we train. It has a diffusion model that understands the world structure, and an encoder that connects the two.
Okay.
So it's basically 3 different models. Now, usually we have to run them one after the other, but because of the very low networking, we're able to get them all to run at the same time and communicate very fast with each other inside the Tranium chip. And that's what's putting us on a path to get to 100 FPS, which is, it can't be done with lots of the other chips on the market.
Yeah. So one of the key innovations on the networking side of things is introduced what we call neuron switch. So it's a V1. So before we kind of had this direct-to-direct connectivity, we call that neuron link. But with Tranium3, we're introducing neuron switch. So that makes 144 of these Tranium3 chips all be able to do all-to-all kind of communication at terabytes per second kind of speed.
Good Lord. I'm old enough to remember Vampire Tap and Token Ring networks, and we were happy to get 1 megabit per second. On a good day,
We've moved on.
On a good day, you hit the little switch, and you might get 100. Terabit per second interconnectivity between chips. I mean, it really can't be understated. If you're an infrastructure nerd like me, chat. If you're an infrastructure nerd like me, hi, welcome. This is a big deal, and being able to keep that latency ultra low and that interconnectivity, it really lets you parallelize the things as you go and really help crunch that down. Now, question for you. I would really love to understand, did you have to do anything special as far as changing your framework? For example, if you're using PyTorch, did you have to go and change anything? Or was this just something that you continue to build on and integrate over at Descartes?
So, at Descartes, we have we're a foundation lab pre-training models on our own. And one of our core pieces is that we have a lot of IP on the system side. So we started out obviously with GPUs, and we wrote assembly for GPUs. We've been doing similar stuff. We've used lots of that IP to make sure that we can really execute well on Tranium. And so we really use our own proprietary, it's not just PyTorch, but a bunch of other tooling that we have. Using the Unimportant team, we're able to port lots of that over to Tranium. And I think that's also the fact that we have this tech at the low-level stage that's close to chip. That's what's allowing us to get the max performance together with the Unimportant team and everything that we've been doing.
What did that collaboration look like?
Wow.
Like how long, if you can tell the sauce, like how long did it take from, idea to implementation?
Wow, I think we had stuff working rather quickly, and we're moving more and more models, and it's so many different components that have to work in order to get this to happen.
Yeah, and this stuff's changing every day, right?
Exactly. I like to say we're in the middle of the AI wars. Okay, it's the World War of AI.
Okay.
And everything is just changing so fast.
Yeah.
But yeah, so we really worked together closely with the Unimportant team. They were incredible to work with us and really to see what our needs were, and to on their side as well, to write lots of code that could adapt to our needs and then support us. And that's been a very, very close collaboration. We're very happy about that.
Yeah.
But basically, in a couple of months, they went from no knowledge of of Tranium, of our stack, to getting a very, you've seen the performance, right? Amazing real-time performance.
Wow.
And that, to be honest, is a big effort. And I think it's the talent in this team is amazing, but also the capabilities that we provide. We have what we call a kernel library. It's called Neuron Kernel Interface, or NICI for short. And that really gives our customers the ability to have full control over the hardware. So they can basically program, for example, how the weights and activation tensors are laid out on the chip, how the tiling works, how schedule and allocation, basically full control, actually right down to the low-level ISA. So that's the hardware instructions. They have that level of control. And that's what they were able to do, is really program the entire model using this NICI kernel language to get the performance they need.
I think Nikki's been incredible. I think we started working together at Purna in July. Back in July, so it's almost half a year. We started without Nikki because we didn't have access to it, and then when we moved to Nikki, it just the world changed. Everything became sunshine and rainbows, and that was really great.
Yeah.
Wow. really like the way you put it, sunshine and rainbows, and it really speaks to the art of the possible here. If you're willing to lean in, if you're willing to partner and kind of roll up your sleeves a little bit, because it's very easy for you to have taken an existing model and just kind of build off of it and spend a lot of time tweaking and kind of trying to make it your own. But the ability to go from 0 in July to a fully functional, customized, parameterized model in real time, as we were able to see here on the demo, that is sensational. There's really no other word to put it.
Yep. Way faster than what you would imagine. Way faster.
Yeah.
When you were building, did you have customers in mind who you were building for and like what you wanted to launch for? How did you go through that and ideate?
So the nice thing about what we're seeing here, we really like to look at this as live visual intelligence.
Okay,
so
let's bring it back up just in case the folks didn't get to see.
Here, we can be a pirate. I can talk as a pirate. Okay.
So you were saying live visual intelligence.
So it's live visual intelligence. It's the model here really understands in real time what's happening.
Okay.
And then also reasons about it and changes it live.
Okay.
And to do that, that's opening up a completely new set of use cases. That it's a new Gen AI category.
Okay.
We didn't have this until we launched this like 8 weeks ago. Until 8 weeks ago, this category did not exist.
8 weeks ago.
Wow.
Yes.
So,
and we've seen this. We've seen adoption across streamers on Amazon Twitch. We've seen adoption with designers. We've seen we're working together with lots of partners in retail and e-commerce to change try-on experiences, like you try on anything that you like. It's just a completely brand new Gen AI category.
Yeah. How do you feel being a pioneer?
Oh, it's.
Wait, you have to change to the pirate outfit.
We could pirate outfit first. We should do what would be a good pioneering outfit? I don't know. Anyway.
I say the pirate for a very good reason.
Why the pirate?
It's a joke.
You're here with us. I'm sorry, I'm out of control.
Amazing. Did you want to do that? Whether here you can be the pirate.
Yar, matey. Oh, I don't look any different. I'm the same.
Yeah.
Now I stink.
We should do it closer. We can do it closer.
Now I got stink lines going. Thank you. My self-esteem's ruined.
Yes.
But no, like in all honesty, to double down on Jasmine's question, somebody's got to be first.
Yes.
Somebody has to take the risk and be bold and be willing to go out there and experiment. And that's something that we really love to re-establish and really reaffirm for our technical folks over at AWS, where we want you to roll up your sleeves and see what happens. If you don't exactly succeed the first time, you fail fast, you iterate, you keep going, then you keep building on it.
Yeah.
But
100%.
Given what you've accomplished, this is pretty crazy.
Yeah.
And I think we're very excited to work with AWS to create this new category.
Yeah.
Yeah.
Dame, what piece of advice would you give to, I know, right? Putting you on the spot, to give to anyone who's wanting to use Tranium, just from your experience, what advice would you give them? Like, what mistakes would you not want them to make along the way?
Well, I think the first piece of advice is really connect with the Annapurna team. Annapurna is the company inside Amazon that's building the chip. They're really incredible, and they be open with them. Don't try to hide too many things. Like no, for real.
Yeah.
As it's moving, the industry's moving so fast. The more open you are, the more both sides can understand each other's problems and really solve them. And I think that's it's always hard to trust someone else in such a fast-moving industry, but it's very necessary.
Yeah.
Yeah, and the way we work with our customers, it's classic Amazon style, right? We start with the customer problem, we work backwards from that, and then try and define shared goals, right?
Okay.
What is the performance, cost, or whatever that what is the metric that they're trying to achieve to improve their particular business use cases, and then we work with them to achieve that goal.
Okay.
Exactly.
Fantastic. This has been really, really educational. I mean, I thought I knew a lot about Tranium and art of the possible. This completely blows the doors off of that. Matt, I cannot really enunciate enough how impressive it is to be able to do this live transcoding on the fly with ultra low latency, as performant as it is, with 3 distinct models all interacting with each other, to go out and do this for us. I mean, this is really helping illustrate, I think, to chat and to anybody that may be watching, what you can go out and build and do, and really go and blaze a trail all on your own in anything you really may have an idea on. You mentioned this didn't really exist a couple weeks ago, and now it is, and now you're opening up a ton of different use cases for that, and I commend you. This is fantastic.
Yeah. All right, where can folks go find the cart?
Thecart.ai, or you can download our mobile app.
Oh!
iOS, Android, yep.
Oh my
There-
goodness!
there
Wow,
we
this
go.
is
Find it
one
on
that my
Twitch.
nephew's gonna love. You show me the tiger.
Oh,
and
yeah.
It's,
Oh,
it's
yeah.
over.
By the
Fullest
way.
auntie point.
There you
Show
go.
show it to your kids, show it to your nephews. They will. Kids can't let go of this. You give it to kids, they stay with it for hours.
You're giving me some ideas on what to do
Yeah.
on those long car rides.
All right, Matt, tell us, how can customers learn more about Trainium? How do you recommend they get started?
Yeah, I mean, just come onto our website. If you search for AWS Trainium, you'll come up to our product pages. I would recommend people look for our in our documentation. So we have our SDK is called the Neuron SDK. So if you search, for the Neuron SDK, there's a whole bunch of getting started guides. You can guides. You can basically bring your existing PyTorch models. Bring them across. If you're really advanced, you can dive into Nikki, as the Descartes team did, and really try and get the best performance for your models.
Yeah.
Nugget of wisdom, if I may. If I'm a partner and I want to get started, does the same apply, or would
Absolutely. Partners, customers, yep, they're all the same. Yep, absolutely.
Awesome. Partners, I'm out there challenging you. I would love to see what you go out and build and come forth with. Gents, it's been fantastic having you on the show with us today. Really appreciate you coming on, and hope you do decide to come back at some point.
Yeah, absolutely.
Yeah.
Had a lot
Thanks
of
so
fun.
much for having us.
Yeah.
Thank you.
Awesome. All right. Hey, stay with us. We'll be back with more, and let us know where you're joining from in the chat.
Please do.